Here's integrated 3. It's problem 1-18. It says Terry's project for the math fair is a magnificent black box that she called a function machine. If you put 3 into her machine, the output is 8. If you put in a 10, the output is 29. If you put in 20, the output is 59. So they're calling these function machines, like you put in your input here and it does something to it and it spits an output out. So it's doing something, usually adding, subtracting, multiplying, or dividing. It's doing some operation on the 3 and giving you an 8. So, and then they give you these other things. These are just ordered pairs, really. So I just write them down like this. Put in a 3, get out an 8. Put in a 10, get out a 29. Put in a 20, get out a 59. In other words, these are ordered pairs that if you actually did want to graph this, you don't have to graph it, but these are just input. The x's are always the inputs and the y's are the outputs. X is domain, y is range. Okay, so they want to know, what would I get if I put in a 5? Well, I think we have to kind of crack the code. Like, what happened to that 3 to make it an 8? So at first I was thinking, well, 2 cubed is 8. Maybe it's 2 raised to a power, but then that was proven wrong on the other 2, so I gave up on that. And I thought, well, maybe it's getting squared and subtract 1. 3 squared is 9 minus 1 is 8. But 10 squared is 100. That didn't work. So you're just doing some guessing. So, all right. I'm going to try to double the 3 and get 6, and then I add 2. Double this. Nope, that didn't work. Okay, I'm going to try tripling it. Triple the 3. 3 times 3 is 9, minus 1 is 8. I think I got it. So if we triple it and then subtract 1. 3 times 10 is 30, minus 1 is 29. 3 times 20 is 60, minus 1 is 59. Now I feel very sure that what I'm doing is I'm tripling the number and then I'm subtracting 1. So that ends up being you can't see what I wrote. That ends up being the rule. I can take this number, triple it, or multiply it by 3 and minus 1. So you're not supposed to really know, like you kind of have to do some guessing to figure that thing out because you just don't know. So you just try, don't give up, and then end up getting it. And then so now I can use this to find out what happens when I put a 5 in. Well, it'll be 3 times 5 is 15, minus 1 is 14. 3 times negative 1 is negative 3, minus 1. Negative 3 minus 1 is negative 4. 3 times x minus 1, well, that would give me 3x minus 1. So I guess the book writes it like this: 14, comma, negative 4, comma, 3x minus 1. Maybe if it was in your homework and you just did it like that, that would be okay too. And then it says, write an equation for her function machine. So, oops, I don't care if you wrote it this way or this way. Well, it's more proper to write it this way because this is function notation and it's a function machine. But this is the rule. We're just going to use function notation.